so much, everyone, for joining us today. And I hope that you're all having a lovely day. We have Joel here from Ceramic, and he's about to host his workshop, Building Web3 Apps with Sovereign Data. And yeah, I'll hand it off to Joel now, and I hope you all enjoy the presentation.
Thanks, Hannah. Nice to be here. All right, so let me jump in. Okay, so as Hannah said, well, maybe before, my name is Joel. I'm a co-founder of 3Box Labs, and we've been building Ceramic. And so today, talk about how we can use Ceramic to build Web3 apps with sovereign data. So maybe let's start with like exploring what actually is sovereign data. So if you think about various types of data in kind of Web3, you have kind of different things you could do. You have like a file and IPFS that has some cryptographic verifiability, but you basically have a hash of it, and then you can retrieve the object, but you can't like change that. You could have a contract on Ethereum has state and changes over time, but that is essentially requires you to sync the state of the entire blockchain. And finally, I guess you have like other types of like cryptographically verifiable data, like a JWT, which is essentially like some data object that has an attached signature to it. But all these kind of things are static, or you need to like sync an entire blockchain to know the state. So what if we can have like singular objects that are mutable and changeable over time, but they have like a persistent identifier that's based on the content, and we want these objects to have like cryptographic access control. So some public key kind of controls the access and about like which updates are allowed to make into this object. And we want it to be scalable. I don't want to have to download an entire blockchain just to sync the comments on a web page and verify those, and verify that the comments kind of came from the right source. So if we can have this kind of primitive, like a data object that's like scalable and have this cryptographic access control and mutable, that's really what sovereign data is. And if we can have that on kind of an internet scale, we can make pretty much the entire internet verifiable. And so we can have this interlinked data objects that kind of are independently verifiable, and we can start building kind of a graph of knowledge of data without having the problem we have today in today's web where links can die and because servers go offline. So with Ceramic, we have created sovereign data objects, and that's basically the core primitives of Ceramic is these objects. So an object is made up of a bunch of different data objects. We call it stream. And so stream is essentially a linked list of signed objects that contains like a pointer back to the previous object. And this is kind of like a Merkle DAG, as a hash linked data structure. And this data object has an immutable, we call it stream ID. And so stream ID is based on the hash of the kind of Genesis commit, the first event in this event log. And this stream ID gives it kind of like a global namespace. So there's like one global network of all of these data objects. And then here we can see that this commit was anchored into the blockchain. So we get the timestamp when it happened. Then there's two signature commits after each other. That means that there was two updates that was signed by the controller of this stream. And then another anchor, another timestamp, another update. And so these updates can contain like a patch or some kind of mutation to the state of this object. And in the Genesis, we have to specify a controller, and that's basically the owner kind of this object. And this is specified as a DID, a decentralized identifier, which is kind of like a standard to represent an identity in a decentralized identity in kind of a blockchain agnostic way. And this allows us to have like full blockchain agnostic system, but also like do key revocation and rotate change keys over time. Then, so once you have this event log, how do you like sync that across the network? So if you're a new node joins the network, you have some stream ID, you want to see what the state of that stream is. you basically ask the network like, hey, what's the latest update of the stream? And some other nodes that has the stream reply to you and say like, this is the latest update. And you sync the entire event log, and you verify the signatures, you verify the timestamps, and basically process all of the events and derive the current state. And so the state transition function used in this system can be different things that there are different stream types in Ceramic. So that could be like a key value store, or use the JSON object, or an append list, or something like that. And all this networking is done over libvirt. Yeah, so what nodes do in Ceramic is keep track of the event log and keep track of the current state of objects. And so each node kind of independently chooses which streams they pin, and they choose how they back up the kind of state of these things. Right. So once we have this sovereign data primitive as like a data object, what can we build with it? Well, so we've been really interested in kind of self-sovereign identity and like how you can build applications around user data. So we've created a framework called Self.id. And so Self.id is essentially a framework which allows you to store data around a person or a human or a user. And the user kind of remains the full control over the data. So you can think of it kind of like as a user table in like a traditional Web2 app, but instead of that being locked into a server, it's shared across all of the internet. So here in this example, we can see that we have DIDs. There are different types of DID here, but I'm not going to go too much into detail. 3ID is a DID method we've created for Ceramic. There's also a DID NFT, which basically allows you to have an NFT as an identity. Then we can see here for each column, there's a data model. So a data model is essentially a special type of Ceramic stream that defines what goes into this column. So each column here gets its own kind of unique name that's based on the stream ID of this data model object. So here we can see that there's a name in the first column, there's some other properties in the second column, and it looks like there's some encrypted data in the third column. The cool thing about these data models is we can have basically like an infinite amount of rows or of columns here. So there's no limit to like how much data you store with the user. And there's also no conflict. Like if someone wants a name property that's just a string, and another application wants the name property that's like forename and surname, then if they were stored in the same column, there would be a conflict, and the apps would kind of break if they try to use each other's data. Now that there's a data model that enforces the structure of the data, there's no conflict. So who controls this data? Well, you could think it would be the data model owner, but it's not really, because it's actually the user. So each user kind of have full sovereign control over their row in this table, in this imaginary table. And each cell here is like an individual Ceramic object. And the user can kind of choose what to do with this data, if you want to update it, if you want to delete some data, what have you. And the cool thing here is this, the data model actually describes the content inside of the cell. So the data model has maybe a name, it has a description, it might contain some other metadata, but importantly, it contains a data schema. So this is normally a JSON schema that describes what format the data inside of the cell takes. And the really nice thing about this is that if you try to put some data into this cell, if it doesn't conform with the data schema, it will be rejected. It wouldn't be allowed to be written. This means that if you're building an application and you actually see that, oh, there's a data model that kind of really is exactly what I need to store with my app, then you can use that data model in your application, and you can know exactly what the format of the data will be, because it's always guaranteed to be structured like this data schema. And so you kind of get this composability of user data. You don't need to think about rely on some application that might change their APIs or to change the data that they store or anything like that. All right, so that's essentially Self.id. I'm going to go through two short code snippets of how you can kind of get started using it. So here we have an example of how to retrieve some data from the network. So we import from the Self.id library. There is this core component. Create an instance of this. We don't include the details. The details are not included here, but oops. You can look that up in the documentation how to instantiate it. You basically need to configure it with like a ceramic instance, which should be pretty straightforward. And then we have an alias here that has an ID. So you can see this is a 3 ID. And then what we do is we just do core.get, and then we get the basic profile, and we get the crypto accounts. So the basic profile and the crypto accounts are essentially data models. So by default, the Self.id framework comes with some very initial primitive data models for a basic profile, which is basically like you have a name, maybe you have an image, maybe you have like an emoji or whatever. And crypto accounts is essentially accounts, other crypto addresses. So it might be like an account on Ethereum, might be an account on Polkadot or Cosmos or Filecoin or something else. And they include like a cryptographic proof that ties to Alice's ID here. So we look here, we actually look up with Alice's ID, which is this 3 ID did. But you can actually use one of the crypto accounts. So if you know Alice's Ethereum address, you can put Alice's Ethereum address here and look up the data. Similarly, we can use the Self.id framework to actually write to into the user's data store. And so here we import an Ethereum auth provider because we're using Ethereum. We want to use an Ethereum wallet. And we import the Self.id framework. And so this is for Self.id for web. So normally, if you have MetaMask or another wallet, there's a window.ethereum object. So you can just get like an address from there. Then you can just create an instance of Self.id. And you do that with the Ethereum auth provider, passing the window Ethereum object and the first address we got back from this call. And here in this example, we connect to a ceramic node that runs locally on this computer. And we use the Clay test network. And now once we have this self object, we can just do self.set and basic profile. And here we set this name to Alice. And now this self object can of course be used to read data as well from Alice's ID or also from like anyone else's if you have their address or ID. All right, so that's just a short overview of like how to use the Self.id SDK and to build apps on top of Ceramic. As you saw, we have just kind of a very simple set and get functions. And when you do this, so this basic profile actually requires you to like have a name. If you try to set something that doesn't conform to the schema that's set here, then that would not be allowed, as I mentioned previously. So if you want to dive into this and like really build on top of it, we have our documentation at developers.ceramic.network. If you go in there, you should click on the tools section and you will be able to find the Self.id framework and some examples there. We have the Self.id website, which is just like a very simple website that demonstrates kind of how you can create a basic profile on top of Ceramic. And if you want to get in contact with us and like have some questions or you're struggling with something, you can go to chat.ceramic.network, which is our Discord server, and hit us up. All right, that's it for the slides. I'm happy to answer. I see there are some questions in the chat. So Let's see. Maybe I'll start with it. Oh shit, that's fine. Maybe I'll start with the chat. So there's a question that's if ceramic is similar to Fluence. It's quite different actually. So ceramic is really intended for these kind of mutable data objects that have this history of data, and you kind of have a state that keeps evolving as the user or the identity that changes it authors something. So Fluence is more like of a distributed calculation network. So I think there could be some really cool things to build that kind of combines the two and stores the output of these computations in ceramic. But I can't say that I have deep enough knowledge of exactly how Fluence work to say how to best combine them. But yeah, they're quite different. There's another question on key rotation. Okay, does it let you change wallet without losing your Web3 identity? So yeah, so Self.id bundles something called 380 Connect, and 380 Connect allows you to connect one or multiple addresses to the same identifier. And so you can add addresses to this or like multiple accounts to this identifier and then remove one. So you can definitely do that. You can like change that over time and choose like which addresses right now are associated with this identifier. Okay, and then there's two questions about like examples you can build for the hackathon. I think it would be really cool to see some different hacks that creates new data models, maybe for like different ways of. Okay, so there's a few different ones. Something could be like various type of social functionality, like you make a comment or you attest to someone's skills. So someone's address and you collaborated with them before, and you kind of attest to like, oh, this person is good at Solidity or JavaScript or whatever. So that kind of like giving each other's attestations could be interesting about skills. And you can have kind of similar type of structures for other type of, I guess, reputational data as well. Another interesting thing could be like if you have a DAO, actually build like some kind of comment system and a Moloch DAO or some kind of thing like that, where in a DAO you always know all of the addresses that are members. So you can simply like query the Self.id data for all of the users and then kind of build a view of what the compound kind of messages from all of the users are. So those are some examples. Happy to like ideate some more if someone has some fun ideas. There's the last question in the chat. Could you speak on Glaze versus Self.id? So Glaze is kind of just a set of tools that you can use to put together an application. Self.id is like a higher level framework that bundles a bunch of these tools together in a way that's more simple to consume. So Self.id includes something called 380 Connect, which allows you to connect to the wallet and connect multiple IDs, and kind of makes the whole flow kind of easier. If you have like more custom needs for your application, it might make sense to just use the Glaze tools directly. Okay, there's a bunch of stuff in the chat. Actually, if you want to read out your question out loud, I think that would be easier. Ayand, if you want to start.
Hello. Actually, I was first I want to make something like an inbox, like something for email, but for Web3. But then I thought that I need a data structure that makes two people, the sender and receiver, and in some case multiple people to access to a single document. And I was thinking that for accomplishing this task, I need a data structure that uses that have a key for the document. That document will be encrypted with a private key, and that private key will be encrypted with the public key of users that have access to it. And both of them, there is a document key that is a encrypted document, and a list of keys for users that have access to that document. I was thinking that whether this exists already in Ceramic, or I could go and make this as a project, or is it even possible something like this? Because it makes a lot of Web2 application needs a data structure like this for things that even in social things. I create a post, I want just my family see it. I must be able to have some access control over it.
Yeah, no, definitely. So it's definitely possible to build. It might be a little bit tricky. So in Ceramic right now, we have support for encryption on kind of the DID level. So we have a library called JS DID, and that allows you to, okay, I have a message, I want to encrypt that to a DID, which I know, so that might be my friend or my family member. And so take the object and encrypt that to that DID. And then I can just retrieve that back, right? The more tricky part is like, so that data object that you encrypted, you can put that into a Ceramic stream, and that should kind of just work. We want to make that simpler so that we have like higher level tools on top of streams in Ceramics. We don't have to like think about, encrypt the object, put it in there. You can just create a private stream that would be like, you select the users, but that's currently not implemented. So there's only this kind of lower level support, but it's definitely possible to build various types of encryption strategies with that. In general, I would recommend if you want to build an encryption system where you want to be able to add more members over time, to encrypt all of the data updates with a symmetric key. And then you take the symmetric key and encrypt that to the public key of all of the people that you want access. So, and if you add someone, you can just encrypt the same symmetric key to the new person. But if you remove someone, you should really kind of like, if you want them to not have access to newer things, you need to generate a new symmetric key and encrypt all newer things with that new symmetric key, and also send that to all of the people who want access.
Thanks.
Yep. Colin, you had a question.
Yeah, my first question was on the Self.id website. I played around with it, and when I linked my DID accounts, there was like that big long hash, and I thought that would be kind of confusing for an end user. Same when I had to sign a message in MetaMask. So is there any better UX for that?
So I don't know, what do you mean by big hash? There's usually two signatures you have to sign. One is like, okay, give this app access, and then the other one is like, okay, tie this Ethereum address to my DID.
Yeah, all of that. There was a bunch of unreadable, or just, it wasn't in English, it was a string of letters and numbers that wouldn't.
Oh, that sounds like it might be a bug, because usually there's always like text in the message you sign, but you can at least read part of it. That might, if you saw that, that might be something wrong with your wallet or with the Self.id website.
All right.
If you actually can replicate that and take a screenshot of it, that would be super helpful. But in general, your question of like making these things more user friendly, we are working together with Spruce and a few other people on the sign-in with Ethereum spec, and so that specification is primarily aimed at signing into backends. but we can actually use it to create something called an object capability, which will allow us to have a session key in the browser and then sign something with your Ethereum wallet that gives that session key permission to write to ceramic streams. So you can actually use sign in with Ethereum to sign into like not a backend, but actually decentralized, sovereign data objects.
All right, cool.
So that's like a medium-term goal for us to like implement that. That's not something that's like available yet.
All right, and then I want something to listen to my smart contract for events that are emitted, and then I want to write that data onto Ceramic or onto IPFS and then access it through Ceramic. How do I do that?
I mean, it sounds like you need some kind of service that connects to an Ethereum node, and then like whenever something happens, it has like Ceramic DID and writes that to Ceramic.
Yeah.
So I guess, yeah, that would need to be like a Node.js app or like whatever language you prefer. And then that just connects to that Ethereum endpoint. And
Okay, would that have to be hosted on AWS or maybe Fluence?
Yeah, maybe it could be done. I don't know if you can like listen to blockchain events like that on Fluence. If that's possible, that would be awesome.
Yeah. All right, thank you.
Cool. Thanks. Blockchain creature. You want to ask your question? All right, maybe not. I can read it. Do you think it's possible to build a safer and more structured referral program? I don't know exactly what structured means. Can you elaborate actually, blockchain creature?
Yes, can you hear me?
Yep.
Yeah, my question was, is it possible, like there are currently different types of referral programs, which let people who refer somebody get a part of, let's say, of a revenue or just a bonus of referring somebody. My question is it even, is it possible to dig deeper and make like one person ambassador linking, which is like having a ambassador who has a self-ID, and that self-ID is connected to all the referred person. Is it possible to have something like that, or is it more like with, yeah, what you said, like with the comments and those kind of things that are already existing on the, let's say, on the web?
Yeah, I mean, so on Ceramic, you can't really make payments inside of Ceramic directly, but what you could do is like, if you establish these relationships as inside of Ceramic and like make them kind of verifiable there. So you have this this ambassador that you mentioned that like connects to a bunch of people in their data store in Ceramic, and then if you have like that and multiple people doing that, and you could potentially like just read that data and do like an airdrop to that later. So that kind of approach could definitely work. Like it's like building like a graph of like interactions, and then reading that later to establish like an airdrop.
I see. That sounds good. Thank you.
Cool. I think we're running up on time, but happy to answer more questions if possible. All right. Well, and thank you, everyone.
All right. Awesome. Thank you so much, Joel, for the awesome presentation. If any of you have any questions in the future, Joel can be reached on Discord in the sponsored channel for Ceramic. So feel free to ask any questions there. And otherwise, thank you so much, everyone, for tuning in. The recording of this workshop will be posted onto the ETHGlobal YouTube. And Joel, thank you so much for taking your time to give a great presentation for everyone. All right, thanks, everyone. Have a great rest of your day.